All right, y'all. So in the last lesson, we talked all about polygons, their interior and exterior angles, how to find those, how to name polygons, and what all the different numbers of sides tell us about those shapes. But today, and really the rest of the unit, we're going to be talking about quadrilaterals specifically, because there's a lot of different kinds. We're going to learn to classify them and look at their different properties to figure out different values and other things about them. If at any point you feel like I'm going too fast, please pause the video to copy down, rewind it, replay it, whatever you need to do. You need to go at your own pace. Let's get started. Okay, so the first thing we're going to do, we're going to fill in this first box here. We're going to fill this in as we go through the notes, and we're going to actually use this packet for the rest of the unit. So in this first box, we're going to put the first type of quadrilateral, and that is a parallelogram. A parallelogram is the first one, spelled like parallel and then O-gram. Okay. Once you've done that, go ahead and flip to the next page. We're going to go ahead and cross off those things there. We talked about those in the first lesson. If you want to refresh yourself on that, please do so. Now, a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. What that means is that GR and MA are opposite sides. GM and AR are opposite sides, so those are parallel. We're going to put that down in this first blank on the left, is that the opposite sides are parallel. So GR is parallel, that's what those vertical lines mean. GR is parallel to MA, and MG is parallel to AR. Now, perhaps more important than the fact that they're parallel is that the opposite sides are congruent. And this is actually how we solve equations and set up problems with parallelograms. So GR, since it is parallel to MA, it must also be congruent to MA. That means they're the same. And MG, being parallel to AR, must be congruent to AR. That means they're the same. So if GR is 10, MA is 10. If GM is 3, RA is 3. So I'm going to go ahead and put in those markings on my diagram. I'm using different colors. You don't have to if you have extra colors, though. It does help out a little bit, but that's totally up to you. Okay. The next thing we know about parallelograms is that the opposite angles are congruent. So just like opposite sides are congruent, opposite angles are congruent as well. So angle M is congruent to angle R. Okay, so I'm going to mark that on mine. Angle M is congruent to angle R. And on your paper, I want you to go ahead and pause the video and see if you can guess which other two angles are congruent. Give y'all a second to do that. Okay, so you should have gotten that angle G and angle A are congruent. So I'm going to mark those. A is congruent to G. Now, the next thing we know is that consecutive angles are supplementary. If you remember from all the way back in the very first unit, supplementary means that the angles add up to 180 degrees. So each pair adds up to 180 degrees, and that's consecutive angles. Consecutive angles are just angles that are directly next to each other. For instance, we've got angle G plus angle M. That's these two angles next to each other. those should add up to 180. And then same thing, angle M should add up with angle A to be 180. Go ahead and fill in the rest on your own. Pause the video. When you're ready, unpause it and copy it down. We also know that angle A plus angle R equals 180. And we know that angle R plus angle G equals 180. So there's 4 pairs of supplementary consecutive angles. And that's going to be another important concept in parallelograms. Now, the last thing we need to know about parallelograms is that the diagonals bisect each other. So before we talk about that, we need to draw in our diagonals. Go ahead and draw those in. M to R and G to A. M to R and G to A. We're going to go ahead and put a midpoint right in the middle. So let's call that point N. Remember, we usually use M for a midpoint, but since M is already taken, we're going to call this N. And the next thing we know is that the diagonals bisect each other. If you don't remember what bisect means, think about that for a second. Bi means to, sect means to cut. So to bisect something, we're going to cut into 2 parts. And specifically, we're going to cut them exactly in half. So the diagonals cut each other in half. What that means is that N is halfway between GA, or halfway between G and A, and it's halfway between M and R. So I can also set those little half diagonals equal to each other. So if I were to say, let's say GN and NA are congruent. Let's write that down. GN is congruent to NA. And I know that because my diagonal's been cut in half. I also know that MN and NR are congruent. Those 2 sections right there. MN and NR are congruent. Now, we don't know that all 4 of those parts are congruent. We only know that each of those halves of the same diagonal are congruent. Some parallelograms of a specific type have some more properties, but every parallelogram has all of these properties. So as I go through the rest of them, I'm not going to touch on them in too much detail every single time because that would take a while. So we're just going to kind of gloss over all of the other parallelograms that have these same properties. We're just really going to talk about the main differences between them. Okay, so in the next video, we're going to talk about rhombuses. But for now, I want you to go ahead and get started on your assignment. When you're done with that, come back, watch the next video, and then we can do our second assignment over rhombuses.